All right. Good afternoon, everybody. My name is Kenya, and I'll be your host as we discuss how to scale developer security using Snyk. Presented to you by Snyk and hosted by Virtual Intelligence Briefing. Today's webinar will be about 30 to 40 minutes, and we'll save the last 10 to 15 minutes for Q&A. So please go ahead and use that Q&A button in your window to ask questions. We'll do our best to answer all questions, and of course, for those that we don't get to, we'll follow up with you after. And without further ado, I would like to introduce our first speaker today, Senior Director of Product Marketing at Snyk, Jim Armstrong.
All right, thanks, Kenya, and thanks everyone for joining us today. As Kenya mentioned, I'm working product marketing here at Snyk. I work across all of our products and very familiar with several. I see some people saying hello in the chat. I really appreciate that. I'd love to keep this as interactive as possible, so I'll keep an eye on the Q&A panel and the chat panel. If I see any questions that pop up as we're going through this, I'll try and answer them along the way, but definitely we'll take some time at the end to answer questions too. So today, just want to do a quick introduction to Snyk for people who may not be so familiar with who Snyk is, but then most of today is going to be a demo. I want to show you what Snyk actually does. We've got a sample app. We'll take you through the paces of what Snyk can do to help protect that application. But we'll set the stage a little bit by just introducing Snyk to everyone. For those who may have sort of only heard of Snyk, but you're not real sure what we do or where we've come from. We've been around for several years now, so we're 4 or 5 years old as a company, but we have millions of developers who use Snyk every day. A bunch of those developers have just come to Snyk on their own to seek out a security solution that they can use with their projects and start testing their applications, testing their code, and creating more secure applications. And then we also have thousands of customers who are actively engaged with us and in using our Snyk platform. As a company, we've grown to over 800 employees. We have $850 million in investment, in several rounds of investment that have come into Snyk. So we've been around for a while, but we're growing like crazy, on all fronts, and really excited about that. And some of the biggest companies in the world are protecting their applications today with Snyk. So we'll talk a little bit more about exactly what Snyk does as we get into the presentation today. But the reason for Snyk is because the world of applications has changed. If you think back even just a few years ago, from a developer's perspective, the main concern they had was their own code and protecting their code. And over time, as we started to embrace more open source technologies and open source frameworks and languages, we also started to use more and more open source dependencies, third-party dependencies that we could bring into our applications that would add functionality that we don't then have to write ourselves every single time. It speeds up application development, but now all of a sudden, a big chunk of our applications are made up of code that somebody else wrote. It's out of our control. And so that opened up a new avenue for potential problems to be introduced into our applications. Fast forward to today, and even more things are now some form of code that produces a thing that runs. So we took all those things as we started to add these open source dependencies, and all this configuration became more and more challenging. We wanted to codify that configuration. We wanted to make that configuration repeatable. So we put things into containers. Now, containers open up a new avenue for security vulnerabilities to be introduced. And we wanted to deploy those containers out to Kubernetes clusters or to the cloud. So we use things like IAC to define how that Kubernetes application is going to look, or how our cloud infrastructure is going to be deployed. All of these things add even more avenues for security problems to be introduced to our applications. But a lot of that responsibility then falls onto those developers or into some sort of DevOps type role or DevOps type process to make sure that two things happen. Number one, our applications still work, because obviously without those, nothing else really happens, but also making sure that they're secure. And so what we've had to do, and the reason Snyk came about, is because of this new modern development process and deployment process, new security tools were needed. We need something that will both empower developers to handle the security, and also enable security teams to have a view of the world that shows applications and make sure that they're secure, and help these two teams work together really in this continuous loop, and providing feedback all throughout this process. And so that's why Snyk came about. We've built this developer security platform to provide this functionality. We focused on developers first and foremost, because a lot of this functionality comes down to a developer. The developers, the application teams, they have the view of the application, of how that application has to work, its functional requirements. And so a lot of this configuration and the code that goes into the application and dependencies are required for that application to work. And the developer uniquely has that view of the world. But security is the ultimate outcome that we want from this. So we've built developer tools first and foremost, with an outcome that's focused on producing more secure applications and being able to deploy and run those applications in a more secure fashion. And it's a platform, not just because everything's a platform these days, but because there's a number of pieces of functionality here that all work together. You can't just protect your code as an independent thing. Your code is dependent on the dependencies that you bring in to make your application work. It's dependent on the containers that it's running in for that runtime configuration. It's dependent on the IAC, which then has links back to what's really vulnerable in my application, because now that's how you're determining what connections can be made or not. And so all of these things have an interdependency amongst each other. We'll see all of these. These are the individual products that Snyk sells as part of this developer security platform. We'll see the functionality of these as we get into the demo. I do want to focus on the qualities of this platform, though, because I think this is a really important point. A lot of tools, and a lot of times in conversations, we hear people talking about shifting left, and shifting left is an important concept, but I think what gets lost in there is people thinking about taking security tools and moving those security tools further to the left. And what that leaves out is the developer experience. Most of the developers that we talk to and we work with, they're interested in security. They know security is important. They want to do the right thing, but they don't have all the details they need, and they're never going to be security experts, right? Their functionality, their main area of expertise is in the code and making an application work, but they want it to be secure. They want that assurance of knowing that their application is going to be okay. It's not going to create problems for their company. So just shifting left and taking security tools and throwing them in front of the developers doesn't really work. There's other tools that are smart about the applications and go out and can do audits and tell you what all your application components are. But again, they might leave out the security intelligence, or they might leave out that developer experience. It really takes all three to have a developer security platform, something that the developers can use and take action on without being security experts, although they have the assurance of knowing that they're doing the right things, and that provides them with that view of their application as a whole, so that they know the things they're fixing will still work with their application, and that their application will produce the intended results. Okay, now with that said, let's get into the actual demo itself here. So I've got an application that we're going to use throughout this demonstration. It sits in a GitHub repo. This is it's a simple application. It's a little to-do list application. Not super important about that piece of it. It's a Java application as well. I could have picked any number of languages, but I just happened to use a Java application for this. And this is it sitting in GitHub. I've also got we can see it here sitting in my IDE. Again, if you really want to see the application, it's available via Git. You can see it as well. But this is the application that we're going to use for the demo today. Now, let's start talking about what this application does and how we can secure it. So you mentioned sort of 4 pieces of functionality here. And we'll kind of walk through these. So first, looking at our own code, the code that I wrote as part of this application, or really I'm in marketing, the code that somebody else wrote as part of this application, that Java code that goes in and makes it up. We want to look at that. What we have is a product called Snyk Code that provides that analysis. The unique thing about Snyk Code is the ability to do this analysis in near real time, right? If you're using SaaS tools, or if you've used SaaS tools in the past, you may be familiar with sometimes those tools taking hours and hours to complete a scan. We've heard reports of sometimes it takes more than a day to complete a scan of the code and do that static analysis. If you think about the developer experience and going back to those qualities we talked about in a developer security platform, and hours is not something that's feasible for a developer. You won't sit and wait hours and hours. for that scan to complete. You need to get your coding done and moved on to the next step so that you can actually deploy it. So our code analysis tool, what we call Snyk code, which is a form of SAST, is really something new and takes literally seconds for it to run. So at this point, I do want to ask a question for the folks who are in attendance. Do you have a SAST tool that you're using today? And we should have a poll that pops up here in just a second. Hopefully everybody sees that on their screen. But do you have a SAST tool that you're using today? And there are a number of options. This may not cover every single use case. Could be that you don't have anything, or at least nothing official. Maybe some people are sort of experimenting with some things or running a few tools here and there. You might kind of have a tool that you're sort of unofficially using, but haven't really made a sort of strategic decision about. You may have tools that you love, right? Or you may have tools that you're using, but it's unfortunate and you're not really happy about being forced to use those tools at your company. So if you don't mind picking one of those, that would be fantastic. Give everybody a chance to answer here. I do see one question that's come up here. Can Snyk code be used with a CLI or via an API or CI/CD pipeline? I'm going to show you here in just a second, actually. So we'll see several different ways, and actually a number of Snyk's products can be used in these ways. But I'll show you here in just a couple of seconds the ways that Snyk code can be used. Okay, the poll is closed. So good mix of answers there. I don't know if everybody can see this. I think everybody can see the results, but I'll just read them off in case you can't. So about half of you said you don't have anything officially that you're using for SAST, for static analysis today. And another chunk, in fact, let's just say there are only about 12% who said you have a tool and you're happy with it, which is not uncommon. I think there's a lot of that. We think back to where these tools started, is, I was talking about sort of the evolution of these applications. A lot of the SAST tools started when you just had the code that you ran, and that was it. And it was probably okay for it to take an hour because you only deployed, once a month or something, right? And so if it took a few hours or even took overnight for a scan to run, it wasn't that big of a deal. You weren't going to be deploying it in the next couple of minutes anyway. As apps have changed, as deployment models have changed, and we've adopted more and more DevOps, that waiting several hours, as with all things in life, it seems, is no longer feasible. We need that instant gratification. Okay, great. The other piece of this, right? So we talked about your first party code, but we also have all these dependencies we bring in as part of our application. We don't want to rewrite a bunch of these functions over and over and over again when somebody else, and particularly these big open source communities, have already written these functions for us, and we can just adopt them into our code and move much faster. As it turns out, as you start to adopt these dependencies, a large chunk of your actual code base is probably written by somebody else, somebody outside your organization. And that's a scary proposition when you first think about it, which is an obvious place where you need to bring in security tools to help check those things and make sure that what you're bringing in is from a known good source and doesn't have vulnerabilities, and that those vulnerabilities, as they get fixed, you move along through the versions and you're getting them fixed. But also you want to make sure that it's not just your dependencies. When you bring in a dependency, that dependency has dependencies on other things, and those have dependencies on other things, and on and on. So there's a whole tree of dependencies and a chain of dependencies that have to be checked as well. And it takes intelligence to be able to not just determine what all those tree of dependencies are, but also how to fix them. And we'll see some of that as we go through this. This is what we call Snyk open source. And so from a product perspective, Snyk open source is the name of the product. Same sort of question here, another poll question, just to see how many of you are using a tool for software composition analysis, a tool that does this third-party dependency checking. In geek speak, that's SCA, software composition analysis. But just curious here. So again, same sort of answers. You may not have anything officially, or you may be somewhere in the middle where you have some tools that are sort of official or unofficial that you may or may not be happy with. Give everybody a second to answer those. We'll see what the results are here. So it looks like, again, on number 2, again, about half of the folks said nothing official, and again, around 11% said that they actually like their SCA tool. They have one and they're happy with it. So very close to what we saw last time. One more poll question for this section. We'll move on. If you were forced to pick, and if you don't know anything about it, just sort of think about this. But if you are doing something today and are familiar, if you were forced to pick, and you could only do SAST or SCA, which one would you start with? So SAST, again, just analysis of your own first-party code, the stuff that your developers write directly. SCA is analysis of those third-party dependencies. And so you could do that, or an option here where you just wouldn't pick, like you just go down fighting and say, you know what, we need both of these things to really be secure. Or you could say, look, there's other forms of testing that I think are way more important than either one of those. So curious what people's opinions are on those. Okay, we can have a second here for answers to come in. All right, let's see what our results are here. So we have kind of a split. So interestingly, a little bit more have picked SCA as their sort of starting point, and then sort of a split between SAST and we need both of those things. I think it's interesting because, again, it turns out that probably most of the code, once you start using dependencies, is somebody else's code. So you look at an app, you count up all the lines of code, and probably most of it comes from those dependencies as opposed to your own code. It's a good reason to start with SCA. The flip side of that is you have more control of your own code. And so SaaS tools are really important for that as well. A lot of really bad things can come from, from your own bad practices, and being able to fix those and address them is important as well. I personally, as you might guess, would say I'd go down fighting, in advocating that you need both. But that's probably not surprising given that I work for Snyk, and therefore have something to gain by that. So just real quick, as we do this, I'll jump into the demo to actually show you these. So again, Snyk code is that tool that will do your first party analysis. Again, very dev friendly. All of Snyk's tools are designed from the ground up for a developer to look at the results and do something with them. And so we want to make these, security is an important aspect of it, but we want to make that security actionable. Tell a developer what they should do based on that security result. The fact that this is real time is really important as well. We want this tool, Snyk code, and all of our tools really to work even in an IDE, that I can just instantaneously check my code and make sure I'm doing the right thing. And then also to work in your pipelines, and also to be able to work, even into production. But getting that instant feedback is super critical for a developer to actually be able to do something about it, and not have to get a ticket much later in the process. And then the accuracy, of course, is important. If you start telling people to fix things that aren't actually problems, then they start ignoring things that tell them to fix things. And so that accuracy is critical. On the Snyk open source side, tracking dependencies is a different sort of challenge, right? You do have to do a very fast scan of those dependencies. You have to be able to build out that dependency tree, but you also have to prioritize things, because there are so many potential vulnerabilities. Usually the number of vulnerabilities goes up in order of magnitude here. When we're talking about these open source dependencies, it's important to be able to produce quick results, but also tell a developer the best thing to go fix. You get this big tree of dependencies, and you want them to focus on the most important things to fix, but also a fix that might have the biggest impact is also important. And it's not going to break the application. That's another important consideration when it comes to providing a fix. We also have to have context into the application. So determining what's the most important to fix a lot of times requires some context on what's actually reachable in the application. If a vulnerability is never callable because of the way the application is constructed, then is it really an important vulnerability for somebody to spend their cycles thinking about and trying to fix? And so all of those things are built into Snyk open source, so that we can provide that fix information directly and quickly to developers. Let's flip over to, let me keep that up there real quick. But let's flip over to our application and kind of see what we've got going on. So So a couple of things I'll point out here. Again, this is my application running in the IDE. You can see the code running here, but I do want to show you a couple of things. So if you're a developer and you're looking to get started with Snyk, the first thing I want to point out, so this is a JetBrains IDE. This happens to be PyCharm. I know I'm using PyCharm for a Java app, and that's weird, but it works. However, I do have Snyk installed here, and I have Snyk installed and doing scans of all of the things we talked about. So my open source dependencies are being scanned here right inside the IDE. My code is being scanned here right inside the IDE. I'll click the button. You can see kind of how quickly this runs. If I click on, if I click on one of these vulnerabilities, it tells me exactly what that vulnerability is. And it tells me what I need to do to fix it, so I can go and make these changes. And the same with my code security. In fact, with Snyk code, I get vulnerabilities, but I also get code quality checks in here as well. So I can click on this code vulnerability. It takes me right to the place in my code where that vulnerability appears, and it gives me some sample fixes that I can apply to show me how I would go about taking care of this particular problem. The other thing I could do if I was a developer, if I was just writing this application from scratch and starting to think about what I'm going to use in it, I could use something like Snyk Advisor. This is free. The IDE plugins are free as well, which is why I'm kind of pointing these out as a place for a developer to get started. Now, the Snyk Advisor today is still early in its release process, so it doesn't cover all languages, but it does cover things like NPM. So if I was using Node and I wanted to go search for packages that were used in my application and get an idea of whether it's a good package to use or not, I could search for that in here. We covered Node, we covered Python, and we do cover some Docker images here as well. But anyway, if I did, like in this case, I looked up Webpack, and I can see that Webpack is a pretty popular package. That's a good signal. That means loads of people are using it. So I'm not the only one that's out there going to get stuck with it. I can see how often it's maintained, how well it's maintained. I can see the vulnerability info about this particular version of Webpack. I can see the community activity. Anyway, as a developer, this is something I can use as I'm starting to sort of compose my application early in the development process to determine if this is a package that I really want to include or if I want to include something else. All right, now let's say I've moved along and I'm using Snyk now in a bigger way. What I've done here is I've added Snyk to, I've added my project into Snyk. I've done that via GitHub integration. We can integrate with just about any Git repo system that you have, including the enterprise versions where you're running them on-prem. I'm just using the regular public SaaS version of GitHub here. And what I've done is I've imported my repo. So I've got this configured to talk to several different organizations, and I've just picked the repo, this to-do list, and I've already imported it. So the nice thing about doing that is when I import this repo, everything that Snyk can check that's available in that repo is automatically pulled in. I don't have to tell it to go do a static code analysis and an open source analysis and a container analysis and on and on. It just says, let me look and see what's in that repo, and I'll run all the relevant checks for it. So I've got my code analysis here. This is Snyk code. This is that first party code analysis. And if I come into this result, you can see here I only have a couple of issues. It gives them a severity rating based on the actual issue that was detected and what we know about that issue, and a brief description of it here as well. If I want to get more info about this, like if I'm a developer and I want to figure out what I do about this particular problem, and I want to see the flow of the code and how this particular vulnerability could potentially be exposed and how data gets to it and through. It gives me that data flow in here as well. And then if I want the fix information, if I click on the fix analysis, it actually gives me another description of what this attack is and the type of attack and how it comes about. But then it also gives me example fixes. So these are pulling from real world examples where the same sort of problem happened and how these fixes were applied in these other cases. So I can see in this, they call it a normalized method, and then did some checks to actually sanitize that input so that this path traversal would effectively be rendered obsolete, right? So it gives me the information I need to know to fix it. You'll also notice here that there's a little icon here to learn about this type of vulnerability. If I click on that, it takes me to Snyk Learn. And Snyk Learn is our education product, if you will, integrated directly with Snyk's results. So in this particular type of vulnerability, here is details about what that vulnerability is. But it also has a nice lesson here. So I can actually practice this. I can see what a directory traversal attack might look like, and I can practice that in the console. I can see several different iterations of it, and it gives me more explanation about how this occurs and why it occurs and why it's dangerous. So good, just built-in learning for a developer to help them understand some of these more common issues that pop up in applications. Okay, let me go back over here. So that was our static code analysis. Let's go over to our open source dependencies here. So I've got a couple different things in here. As I said, most of the application really is Java. There's a little bit of Node here. I'm going to stay focused on the Java portion of this. So if I go into this, now we're looking at the open source dependencies that make up this application as well. And if we start to go through some of these, I won't go through every vulnerability, obviously, but show a couple bits of important information. So here's a vulnerability, and you see the typical things you might expect to see with a vulnerability. There's CVE information and CWE and a score for it, high, medium, low, critical severity ratings. All of that is just basic, details that come from the vulnerability itself. But what we want to provide to help a developer understand what to do is, more relevant sort of metadata and details about the vulnerability that will help them prioritize this vulnerability and know what to fix, and also how to fix it. So this one, for instance, we give them the details about what version to move to in order to fix this vulnerability. We saw that in the IDE as well. We see it again here. We see in this case too that this vulnerability is potentially reachable in the way our application is constructed. And so that raises this priority score. The priority score is a way of looking at across all these vulnerabilities and saying, which of these should you probably focus on first? And it takes a number of different things into account: reachability, exploit maturity, the rating, the severity rating of the vulnerability. Does it have a fix available or not? If it doesn't have a fix available, then maybe it's something I don't want to pay as much attention to. So we can see here it's reachable. This one has a mature exploit. So even though it's a medium severity vulnerability, with all these things combined and the fact that this is a fixable thing, this is probably an easy thing for us to knock out, and important because of these other factors as well. We can see some analysis of that reachability here. And if I want to, I could go into my POM XML and I could make this change myself manually. I could do that back in the IDE, or I have the ability to click a button and Snyk will fix this vulnerability for me by opening a pull request back in my Git repo. Now, in this case, I told it to just fix one vulnerability. So it has that one pre-selected for me, but you can see all the other things that we could potentially fix with a pull request for this particular application. Before I do that, I'll go back here. Looking at this next vulnerability, you'll see that we actually have a little bit of different information. So in this case, we've done the analysis of this vulnerability and said, because of this vulnerability, it's not likely to be exploitable because of the requirements for it. What's needed to get to this vulnerability is having this polymorphic type handling. We don't have that enabled. And so therefore, in this particular application, this vulnerability is probably not exploitable, even though there is a mature exploit for it. So that's helpful as well in terms of determining what to fix. I can also look, we talked about having the transitive dependencies. I can see all the dependencies and the dependencies of my dependencies and exactly where a vulnerability comes about. I can also choose how I want to fix vulnerabilities. So I can open a PR that will just fix everything for me, or I can pick, other more directed and more targeted pull requests to focus on particular packages. And again, if I do that, it also tells me all of the different vulnerabilities that could be fixed by moving this, in this case, moving this X stream from 149 to 1418, all the different vulnerabilities that I have in my results and things that can be fixed by upgrading that particular package. So Very helpful, I think, in terms of how a developer would look at this information and how they would go through it. Again, part of this as well, when it comes to these, especially with these dependencies, these open source dependencies, we don't want to just say, here's the latest version, just go to the latest version and it'll fix all these problems. What we want to do is provide the fix that's sort of the easiest one to get to and the least likely to break your application. And so that doesn't mean necessarily the newest version. It might mean some version in between that takes care of the vulnerabilities, but that doesn't, that has less likelihood of breaking your applications. We also want to look at all the different vulnerabilities we see here. There's 107, and several of them will come back to the same package, right? The same package that I installed. And it could be via that transitive set of dependencies. And so look at all of that together and figure out what is the fix that's going to take care of as many of these particular vulnerabilities as possible, because they might all have slightly different versions that they want to go to. But if I go to the right version, I can apply one fix and take care of as many of these vulnerabilities as possible. The other aspect of it too, because we're pulling in these third-party and open source dependencies, is we also want to look at the licensing of those packages as well and make sure that we're not installing and using anything that's going to violate, things that our lawyers don't like and going to put us out of compliance or force us to do something with our application that we don't want to do. And so we also check those licenses for those open source dependencies as well. Okay, so that's our first party code analysis and the open source code analysis. Let's go back over. I don't see any new questions in here. We can, and I'll show you. So I didn't show you doing the checks yet in CI/CD. There was a question about that earlier. We'll get to that in just a second. So I'll show you that coming up. We showed you checks in the IDE. We'll also do some CLI checks here in a second as well. So you'll see that coming soon. All right. Now, in this application, you may have noticed that I am deploying this via containers. And that's a very common deployment method today. Loads of people putting their stuff into containers. Again, it helps to keep that configuration the same from point A to point B and keep that complexity out of it. And so containers have become this really popular deployment option. The problem with containers is very similar to what we saw with open source. We're pulling in a container that has a bunch of stuff in it already before we start adding things to it. Those are Linux packages for the most part. I'm assuming most people are using Linux containers and not Windows containers, but either way, it doesn't really make a difference. You're pulling in a bunch of pre-installed binary packages that maybe your application uses and maybe it doesn't, but they tend to have a lot of vulnerabilities in them. And so, if we go from code to open source, and that was an order of magnitude increase, it can be another order of magnitude increase to go from open source to container vulnerabilities, because these containers, particularly based on how you start building your containers, can have hundreds, if not thousands of vulnerabilities when you get started. And it can be very difficult to reason about those vulnerabilities and how they might affect your application. So going back to our poll questions, real quick one here. Just curious, how many of you are running applications in containers today? And we've got several options for this as well. If we could pop that up real quick. Can you use the poll running? I don't see it. I didn't see it pop up. Oh, somebody said it is running. Okay, good. Maybe on a different screen for me. Okay, if we can close that real quick, look at the results.
Hey, we actually don't have that poll up right now. So if anyone wants to just mention in the comments or in the chat, that would be awesome if you want to answer in there.
Okay. Yeah, if you're running, I'm just curious if you're running apps in containers or not, just let me know. And if you do type it in the chat, just how many, like, is it 50% of your apps, 100% of your apps, 4% of your apps, just put an estimate in there for how many you're running. The other part of that too is, whether you use containers or not. And if you're using containers, a lot of you are probably using Kubernetes, but even if you're not using containers, you're still probably deploying things to cloud infrastructure, internal or external, cloud infrastructure, private or public, I guess. And you're probably using some form of IAC to do it. Very common sort of deployment pattern today for these, especially for these modern apps where we want to be able to deploy things, spin it up and tear it down as fast as possible. Another place where, all kinds of problems can come up if you, pay attention to the news, you'll see a breach, on a regular basis. And almost always that breach starts because something was misconfigured. A gateway was misconfigured, a server was misconfigured, storage was misconfigured, and it allowed too much access to somebody who used that to get in. And from there, they start to, poke around and find, other things that they can get access to. But these misconfigurations are a huge problem that people are trying to solve. We'll skip the poll question here again on IAC. If you have a second, you can just type it into the chat window. What forms of IAC do you use today? So it could be Kubernetes. I would consider Kubernetes a form of IAC. Terraform, CloudFormation, Pulumi. There's all sorts of things. Ansible. There's all sorts of things out there that you might consider IAC. So if you could pop that into the chat window, that'd be great. I see lots of Terraform coming in there. On the container side, I see some people said 90%. I see some people that said they were POC. I see one that's 110%. That's pretty impressive. So, on the container side, pretty mixed, and a few no's in there as well. Nothing is being run in containers yet. I see on the IAC, Terraform, AWS, and Kubernetes are the three that sort of pop out the highest on those unofficially. So very common, I think, use case patterns there. In the interest of time, I'm going to move through these fairly fast. So I'll do the slides just in 1 second each. So on the container side with Snyk, again, if you've been using containers for a while, you may have run some container scans with some other tools. They all produce this list of vulnerabilities. It doesn't really matter what tool you pick. What we wanted to focus on is taking that vulnerability information and making it something that a developer could do something with, reason about, right? A list of 1,000 vulnerabilities is very hard for anybody, even a security expert, to reason about and know what's step one that I can take to get rid of some of these things. And so we wanted to make that a little more obvious and easy for a developer to be able to do something about this. We want this to be a tool that runs, wherever you might have containers. So putting it into the build process, putting it in early in front of a developer so that they can actually do something and make that part of their application is really important. But containers are, they are the running object as well. And they have, as they're running, there is an effect on what can happen in the container, what could happen to vulnerabilities in the container. And so we want to look at that too. So we look at the containers in Kubernetes as well as throughout your CI/CD pipelines and all the way back into even as early as the IDE. I'll show you that in a second. And then the same with IAC, loads of different formats that you might have. Ultimately, what you want to make sure is that your cloud, your application, the things that you're deploying are configured correctly. And you may be using some compliance benchmarks for that or AWS best practices to do that. We've built all those rules into Snyk IAC so that they're all available to you already out of the box. You don't have to think about that too much. But a number of people do want to add their own custom rules, their own custom policies and checks in there. So we have that capability as well. Again, the idea here is that we want to find the things that are wrong, but we also want to provide a developer a result that says, here's how you go and fix that really quickly. Another important aspect of IAC, particularly with various forms of this, the problem might be slightly bigger or slightly smaller, but drift is a problem. We deployed something, somebody went into my AWS console and changed it. Maybe they meant to do it just so they can install a patch real quick, and they intended to change it back, but they never did. But they did it through the console. So now what my Terraform says is supposed to be running is not the thing that's actually running. And then we also find people as they adopt IAC, they've got about half of their infrastructure that's under the management of Terraform and half of it that's still just manually deployed via some other tool. And that's a place where drift can happen as well. And we want to help people find those things. So our IAC tools can do all of these things. Let's flip over to back to the demo and look at Snyk containers. So first thing, as I said before, when we looked at the IDE, right? So we have Snyk infrastructure as code and Snyk container. in the IDE. So those same checks are being run, and you'll see the more details on the checks here in a second, but we're running these checks within the IDE as well. We get the information about how to fix it. When I click on this problem, it takes me straight to the file, into the line that's actually being identified here with information about how to fix it. And on the container side, it scanned my container. It's focused on the results that produce the sort of the biggest bang for the buck on the container side here, which is let's pick a different base image that doesn't have as many vulnerabilities in it. So again, from a developer's perspective, I get immediate results right here in the IDE. But going back to our project here, let's look at, we imported this repo, and our repo had a Docker file in it. And we, as part of that import, we looked at the Docker file to identify vulnerabilities. Now, when we're scanning a Docker file, we're not scanning the actual image. We're assuming kind of what that image would look like once it gets built. And we're really focused on what you're building that image on top of. The base image is what we call it in here. So we provide recommendations for a better base image for this particular application. So we're starting with Debian 8. You'll notice here, Debian 8 is no longer supported by Debian. That's a big problem. That's a big red flag. So that's probably something that we want to fix for this application. But we do provide a couple of alternatives that you could use as the application owner to run this. Now, again, I could go into my Docker file and I could change it so that I start from Debian Bullseye if I wanted to, or I can let Fix do that, or Snyk do that for me by opening a Fix PR. And I could even automate this if I wanted to, so that in this case, it's a major upgrade, but if there was a minor upgrade, a smaller change, I could make a Fix PR open automatically. But again, it will go and it'll change that Docker file, and it will kick off all the processes I have in the back end to test those PRs and look for something. Now, again, with a Docker file, I'm only scanning that base image, right? I'm only sort of detecting the place where this final image starts. It's not the full image, but I do have the full image scanned. So what I'm actually doing in my with Snyk here, now I have this all happening in GitHub. It doesn't have to be in GitHub Actions. It could be whatever your CI tool is of choice. You could do pretty much the exact same thing. But what I have here is GitHub Actions that will run checks on my application as things are pushed or pulled or committed, or anything changes basically. In this repo, I run Snyk over and over again. And I've split my tests up. So I've got my container tests happening here, and I've got actually got Snyk open source tests that are happening here. I could do Snyk IAC tests. I could do Snyk code tests. Anything could be done here. Those are the two that I happen to have. So I'm running these tests. So in my pipeline, I push something in, I build the container, I test the container, and I get the results back into Snyk. So if I go back over here, that's what I'm seeing here. It's these linked images. So I have the Docker file, and now I also know which images in my console here have come from that Docker file. So these got built in the pipeline. I scanned the image as well in the pipeline, and I have a result here. So I'll just pick one. They're pretty much the exact same image, so it doesn't make much difference. But again, same sort of thing here. This is the base image that's part of my final container. But because this is the final container, I have all the other vulnerabilities that go into this as well. So this is the real final view of the container. Now, we talked about things like exploit maturity before. That's part of Snyk container as well. Again, I can filter based on the severity of the vulnerability. I can filter based on exploit maturity, all those kinds of things. On some of these vulnerabilities, and I don't have one off the top of my head, but on some of these, and this is because it's Debian 8, I don't have the details here as well, but you see here, it's got an NVD severity. If Debian said that this vulnerability was unimportant, we would change this criticality from high, which was what NVD said, to what Debian said, which was it's unimportant, or it would be low in our case. So we have that information built in as well. Again, the idea here is providing the developer, number one, where did this come from? This came from your base image. Maybe you don't want to go fiddling around and getting into the details of a base image, because it's just going to change every time you change your base image. So maybe you just want to pick a better base image. But then I can also see the package dependency path here. to see exactly how this got into my container. If I wanted to only focus on vulnerabilities that I introduced to the container, so forget about the things in the base image, I only want to focus on things I introduced, I can make that selection as well. I can actually see the Dockerfile command that also introduced this vulnerability. So I know, the package information, but I also know exactly where in my Dockerfile that package comes from. And in this case, I'm installing this database package, which is introducing a bunch of vulnerabilities into my container. So that gets us a little bit on the container side. Again, I can fix these things via the fix PR. I could do this via any CI tool. We also have the ability to scan this container running in the Kubernetes cluster. I don't have a Kubernetes cluster sitting here available right now, but I would get the exact same scan results, but I would also get real-time information about exactly which containers are running in the Kubernetes cluster. If I wanted to scan containers in a registry, I could do that too. And then the final thing I'll show you here before I wrap up and we go and answer some questions. And by the way, if you have questions, now's a great time to pop them into the Q&A channel, because I'll be wrapping up here in a second, and we'll start to scroll through those. The other side of this is IC. So again, in this particular case, I'm deploying this to a Kubernetes cluster. So I have my YAML file here that helps me with the Kubernetes deployment. I'm also got infrastructure that I can set up in AKS that's deployed via Terraform. So I've scanned those files as well. If I click on this in the Snyk UI, I get this nice pretty view of the results that are found. And if I click into it, I also get, it highlights exactly where in the code this particular misconfiguration is, what the issue is, the impact, and how I can resolve it. We saw that same sort of thing in the IDE, and that's nice because it takes me directly to the actual file itself. But I can see this anywhere. I could run this in CI if I wanted to and get these exact same results. What's really sort of common with IAC, and in particular with Terraform, is people will run this as part of their CI, but they'll want to scan their plan output. And that's definitely something we can do as well. Let me skip over to this one. Actually, let's go here, I think. One of these windows, I've got it. One second, I'll find it. Well, in the interest of time, let me skip over it. We've got the ability to scan here it is, the plan output. So I found it. I just wasn't clicking on the right tab. So in this case, I've got, this is a different directory, but I've got an actually deployed environment. So you can see my Terraform state file that's actually stored right here in my system. Probably not the best place for it, but for demos, it works, right? So I've got the Terraform state. Now, what I've done here is I've taken this over on a Terraform plan. I outputted that plan to a binary file, converted it to JSON, and I can test that with Snyk as well. In this case, I'm doing a planned values scan, which is looking at all of the configuration settings that are in that state file and running a Snyk IAC test against those, so I can see that output in here. If I wanted to do JSON, so I could take this and I could swizzle it around and do stuff with it via my CI tools, I could get that output as well. But this plan scanning is really popular, in particular with Terraform. The other thing that we have sitting in one of these windows is, I mentioned the ability to run custom checks, and you'll see as it runs here, it's using custom rules. In this case, I've got a custom rule set up that's looking for labels being applied to my Kubernetes deployment. So there's a set of labels that Kubernetes says you should probably use these. These are best practice, and I could, in this case, in my organization, I think that's really important. So I've set up a custom rule that will check that Kubernetes deployment to see if those labels actually exist, and if it doesn't, it will flag those things for me, so I can write custom rules to do those kinds of things. All right. One last thing before I go to questions is you know, this is all sort of great if you're a developer. If you're the admin of this, there are potentially some other things that you want to do as well. You want to get reports. You might want to be able to set policies across your entire organization. All of that functionality is available in Snyk as well. So I've got, you know, good reports in terms of the total number of issues that have been found, license issues split out from security issues. I can see fixed trends. So are people fixing these on a regular basis? How long does it take for people to fix them? I can split this into, you know, all the different issues, all the different dependencies across projects. So I can sort of see, you know, where the biggest impact would be to fixing some of these issues as well. So, so a nice bit of reporting. I can get this information out via API as well. Or if you want to run tests, you can run most of these tests via API as well. So a lot of the interaction with Snyk can actually be done via the API. We can also set policies. So, you know, if we want to take an entire class of vulnerabilities and we want to raise the severity of it so that we force people to pay more attention to it or ignore them so that people don't have to pay attention to it, we can do that as well. You can see I've got Jim's special policy here. And in this case, I'm looking for particular vulnerabilities, and I'm saying to change those vulnerabilities to critical. In this case, you can see I've got an example app where I've got Vim and Git installed in my containers, which is horrible practice. And so I've raised the severity of that to critical, because I don't, you know, as a production, at the production level, I don't want Git in Vim inside my container. They should be removed. And so I've set these things to raise a critical vulnerability when anything is detected. So again, I can set policies and I can choose how this policy applies. So I can apply it to just specific groups within Snyk, to specific you know, projects and those kinds of things. There's different attributes I can use to apply those policies. Again, at that administrative level where you're trying to affect, you know, numbers of groups of people at the same time. Okay, that was a whirlwind demo. Lots of things to see in just you know, a handful of minutes. On this webinar. I'll just wrap up with a couple of things. You know, the way people typically implement Snyk is to put Snyk everywhere, right? We want to make this as easy as possible. We want people to test and test early and test often. We don't charge for the number of tests you run. We don't charge for the number of applications or resources or anything you have. When you've got Snyk, we want people to be able to test as early and often and make it part of your regular practice. And so it's built in, you know, from the beginning and all the way through how things are actually running in production. We've moved really fast over the last, you know, over the last year, the last 4 years, really. But just to give you an idea of all the, you know, improvements and changes that have come about through the last year. This slide is really hard to read, but that's because we've moved so fast and there have been so many new things that we've released. So I will end up my chattery portion of the presentation here. If you want to get a more detailed demo and get your specific environment as part of the demo and talk about that, you can do that at this link below to schedule a demo and talk to the Snyk folks. Let me look through some of the questions that are open in here. So I see a question here about Snyk open source, the fixed in version. Is it smart? In a way, will suggest a version of a package that has a specific vulnerability fixed, but does not introduce additional new vulnerabilities. Yeah, so that's a great question. And that goes back to this whole developer experience. There's several factors that go into that fixed in version. We want to fix a particular vulnerability, but there could be a bunch of vulnerabilities that affect the same package. So we also want to introduce a fix that will take care of as many of those vulnerabilities as possible. We also don't want to just tell you to go to the latest version because that might break your application. So there's a lot of balancing that goes into what version we suggest you move to in order to fix some of those applications. For some vulnerabilities, there isn't a fix as well. And we actually do curate some fixes of our own, some special patches. So there may be a place where we suggest a fix that's a proprietary fix from Snyk. So some of that goes into it as well. But there's a number of things that go into it to make those fixes more intelligent and, you know, introduce as few new problems as possible when we suggest a fix. I see a question here. Is Snyk container used mostly by DevOps? I think Snyk container is used by the people who are responsible for the containers. And I think that's sort of organization by organization. That can vary a little bit. We see groups where the developers are allowed to go do whatever they want. They know it's running in containers, but they're allowed to pick the base image that they want to use. And there's very little control over that. And in that case, they use Snyk container directly. We see some organizations where they're trying to put a little more control over it. So they've got an internal set of, call them golden images, if you will, and they want their developers, they would prefer their developers to use that. In some cases, they require their developers to use that. In which case there may be multiple steps along the way. There's that internal team that's building those internal base images, and they may use Snyk and they'll get the base image recommendations, and they're sort of responsible for fixing that internal golden image. But then the developer team is only responsible for the things that they introduce to the image. So anything that you add as an app team, you're responsible for. They use that filter at the end that you saw there to sort of weed out those other things. And there's ways you can automate that as well. And that applies to all of Snyk. There are ways that you can ignore vulnerabilities en masse, either during the test or via those policies. So there's a number of ways you can handle those. But I think to answer that question, it really kind of depends on how you handle and build containers. What's an example of a license issue? So the licensing is really there to check, when you're using those, in particular, the open source dependencies, they all have different licenses, right? And the licenses themselves, depending on what your own legal team says, some of those licenses may be things that you're perfectly fine building into your app. Some of them may require you to publish your own source code if you use those dependencies, and you may not want to do that. Some licenses may, I don't know, there's all sorts of things that a license could require you to do. And if you incorporate that dependency into your code, you're sort of incorporating that license into your code as well. And so, having a good handle of those licenses and which apply to which dependencies and which are allowable in your organization is really where this comes in. So it's going to depend a little bit on your legal and compliance team. But that's the sort of thing we're checking. These are all, open source licenses that have various terms that come with them. Let's see. I think that pretty much wraps up all the questions. We're right at the top of the hour too. I see one about authentication, a number of different ways you can authenticate into Snyk. You can set up SSO, I think is sort of the gist of the question here. But you can set up SSO so you can get into Snyk. Things I didn't get to as well. You can also, there's an API, as I said before. So if you want to do everything via API, you can do that. In fact, I would say in a lot of cases, our customers and the real users of this, the developers, don't actually see the Snyk interface that I showed you today. It's nice to be able to see it, but they'll see it inside of GitHub, for instance, if you're using GitHub. So I've done those checks in GitHub, and I've actually taken and outputted the results from the Snyk open source test directly into GitHub. So I can see the results right there. They might use an API, you might use Jira or something like that to create tickets. You can do a lot of that through Snyk as well. So a whole bunch of things that I didn't get to because we ran out of time, but that you can do with Snyk and integrate it into your processes. So I hope that was helpful. I know it was a whirlwind, as it always is when you try and cover something this big in a short period of time. I appreciate everybody sticking around today. I appreciate all the good questions and in interaction throughout the presentation today. That's always good to see and very helpful for me. So I hope you have a great rest of your day. These slides and the recordings of the presentation will be made available afterwards. So thanks again, everyone, and have a great rest of your day.
Thanks, everybody.